In this lecture, we're going to study another example of a strategic form representation in a game with imperfect information. Let us consider now the Alice, Bob, and Carla extensive form game that we already studied in the past. Recall that this is an imperfect information game that we already saw in previous lectures. So now let us see how we can build the associated strategic form from this game. Remember that in this game, Alice moves first, choosing either a red card or a black card from a full deck. Then Carla enters the room and Bob makes a statement to her, and he either says that Alice chose a red card or Alice chose a black card. And then Carla finally must guess the color of the card. So here's the idea, right? Alice first of all chooses the color, then Bob makes a statement to Carla, and then Carla finally makes her guess, as we can see in here. So how are we going to represent this strategic form? Well, first of all, we will denote Bob's strategies as XY, that is to say, as a pair. This means that I say X if Alice chose a black card, and I say Y if Alice chose a red card. Remember that it is Bob who makes a statement to Carla. Now, Carla's strategies will also be pairs, and again XY, which means that I guess X if Bob tells me black, and I guess Y if Bob tells me red. That is, whether Bob tells that Alice had chosen black or red, respectively. Very well, so now let us analyze the strategic form representation. First of all, let us just consider this top left table here. Notice in this column here, Bob's strategy is RB. So remember this notation XY. Thus, RB means if Alice chose a black card, I say red, and if Alice chose a red card, I say black. So notice how in this strategy Bob plans to lie. He plans to lie in both cases. Now, this behavior of Bob from this strategy is reflected not only in this table but also in all tables where Bob plays this strategy, the strategy RB. Very well, let us now consider a strategy of Carla, for instance this strategy BR. So again we need to recall this notation of XY, and thus Carla's strategy BR means if Bob tells me black, I guess black, and if Bob tells me red, I guess red. So notice how in this strategy Carla plans to repeat what Bob says. Now notice that here, given the number of combinations and strategies, we have 4 tables, 1 table for each possible strategy of Carla. It is also important to see that Alice's strategies are not pairs. The strategy of Alice is either black or red. This is because Alice is the one who starts the game by choosing black or red. Now, from what we know, in order to solve an extensive form game, we could simply construct the associated strategic form game and look for the Nash equilibria. Nevertheless, as we saw in the previous section, in the case of perfect information games, not all Nash equilibria of the associated strategic form can be considered rational solutions, and we also introduced the notion of backward induction to select the reasonable Nash equilibria. So what we now need is a generalization of the notion of backward induction that can be applied to general extensive form games. This generalization is called subgame perfect equilibrium. However, to introduce it properly, we must first define what a subgame is. And so this is what we are going to do in the following lecture.